All right, it's 10:57. Let's go ahead and get started. Our next speaker is Matt Jolly. Matt Jolly is a research ecologist with the Rocky Mountain Research Station and Missoula Fire Sciences Laboratory. He's going to talk about using the WildfireSAFE app to assess and communicate severe fire weather conditions and share some case studies from the 2020 fire season. Let's get the presenter role transition to Matt. Thanks, Wes. Thanks for joining us, Matt.
All right. Good morning, everyone. For the folks that's still morning for, good afternoon otherwise. My name is Matt Jolly. I'm a research ecologist with the Rocky Mountain Research Station, Missoula Fire Lab. Just want to share a little bit today with about an app that we've been working on called WildfireSAFE, and then also a little bit about some lessons learned and some things that we did working with Area Command this summer to support North Ops and South Ops. So,
hey Matt, yeah. It looks like we've got. Oh, there we go. We see the screen correctly. Okay, go ahead.
Okay. So this summer for Area Command was interesting, as it was for anyone that was working anywhere, especially to do this kind of work remotely. But essentially, what we were tasked to do was provide strategic intelligence for things that you normally wouldn't think of in fire management. So things like when is an appropriate time to transition a team, or when is an appropriate time for a team to R&R in place, or to ease in so that someone else can cover the fire. So we're asked to summarize information across priority fires for North Ops and South Ops, and to do that, we're able to leverage something that we've been working on at the lab, this Weatherstream service that allows us to produce a 16-day, up to 16-day forecast in the format that's compatible with FlamMap and then the command line Farsight tools. So using that point forecast, we're able to essentially extract a real-time conditioning period from the RTMA, a short-term NDFD forecast, and a GFS forecast to produce a deterministic near-term fire behavior simulation for each of the priority fires for North Ops and South Ops that Area Command was essentially trying to provide information for and simulate 14 days deterministic fire spread. So we were able to evaluate it and also intersect it with things like values at risk. So using 14-day simulations to intersect with estimated population densities to show daily impacts of each fire across the area, and summarize those fires in some fairly unique ways. One of the ways that we did that, which is a little busy but kind of interesting, so I thought it was worth sharing, is we were able to take the team timelines, glide paths, transitions, and overlay periods of active fire growth. So using the 14-day simulations, estimating each one as relative growth, so showing periods of high, moderate, or low growth, and also being able to see where a team times out or where teams are transitioning, so that those time periods could effectively be adjusted if necessary to ensure that teams aren't transitioning during periods of large fire growth. One of the things that we've been working on as well is providing a way to look at season-ending events. So using gridded surface data, gridded fire danger data, we're able to actually summarize incident by incident a season-ending event probability graph, which is fairly normal for term analyses, but it's not. But what's unique about this is that we're able to clip out an area and summarize every pixel within that area to provide the probability curve. So in this case, we were able to scale that up to the size of a PSA. So for the Northern Sierras PSA, just for an example, and hopefully over the winter, we'll be able to accomplish essentially a library of these season-ending event curves for all the PSAs, probably starting in the West, and have those available for before the season starts, so that at least at a PSA level you can see when those season-ending events are likely. So the WildfireSAFE app is something that just transitioning into that. We've been working on steadily. It started out as a prototype for the Northern Rockies, and this summer with COVID conditions and the uncertainties around resource availability, there was a need to fill an informational role to provide fire potential metrics for each incident specifically for resource prioritization at the geographic area level. The app has really three pieces. It has the metrics that we generate about the fire environment, has summaries of the values at risk, and then currently has local COVID-19 county level trend status. It has an automation piece where we tap into the real-time Irwin fire reporting through the NISI Open Data active incidents feature service, and that allows us to get new starts and update those starts in the application within 5 minutes after the fire being reported. So the nice thing is it's interagency, so that it's available for both states, federal partners. It's a very simple registration process, and you can use the app almost right away. The app itself is web-based and mobile, so it's very platform friendly. Depending on what platform you're using, it's going to look a little bit different, but it scales from a phone to an app. It's built as a progressive web app, which means that it will essentially store the code on your phone and allow you to add a desktop link to on your home screen, or on your mobile device, so you can just click on the icon, it brings you into the app. It has mapping and incident summaries, and then it has a decision dashboard that allows you to summarize across incidents. So just some screenshots of what it looks like. The desktop mapping application shows points colored by the severe fire danger index, which I'll talk about in a minute. But it also has a lot of other useful layers. So it has
I think we lost Matt. Can you guys hear me all right?
I got you, Diane. Let's give Matt a few more minutes and see if he can come back in. I'm going to write him.
All right. All right, stand by, everyone. Technical difficulty. Hopefully Matt's not still talking, wondering why we're not listening. I believe Wes is reaching out to Matt. Sounds like Matt has some technical difficulties on his end. I think that Matt Jolly is back online with us. Perhaps we will transition back over to Matt and he can finish his section, and then we'll wrap it all up with question and answers when Matt is finished.
Okay. Can you hear me okay?
Yeah.
Outstanding. I apologize. For some reason, my internet connection just decided to reset right in the middle of talking. So I was just talking along happily and looked up and the mic was gone. So we're going to continue with the discussion of the WildfireSAFE app and make sure that can you verify you can see full screen?
I've got full screen.
Outstanding. So I'm not sure where we left off, so I'll start back here. The WildfireSAFE app is really composed of three pieces: metrics, the things that we summarize by fire about the fire environment, the values at risk, and then currently summarizing local county level COVID-19 trend status for by fire. The automation piece where we tie into Irwin through the NIFC Open Data active incidents feature service. That allows us to get new updates for fires every 5 minutes. So we can capture emerging fires and deliver that information rapidly through the web interface. So the interface is actually web and mobile application combined. So when you open it up on a desktop, it functions as a inside a web browser, but when you open it up on a mobile device, it installs as a progressive web app. We have mapping and incident summaries, basically for every fire across the country that's actively burning, and newly reported fires as well. So the decision dashboard is a piece that I'll show you examples of here as well, which summarizes a list of fires by organizational area. So the desktop mapping application takes the active incident points and summarizes them by the severe fire danger index, which I'll show you what that is in a minute. But there's also underlying layers that are useful. So things like the drought monitor. We have a relative NDVI from NOAA NESIS. We have active fire products from both MODIS and VEERS for 24, 48, 72 hours or 7 days. And the current perimeters from the National Incident Feature Service. So it allows us to summarize by location. So we basically, for each fire, we have an analysis area. For that analysis area, we summarize the fuels, weather, topography, values at risk, and then we have a field observer form that allows you to submit fire behavior observations back into the application, and those observations are made available to everyone that has a user account. So some of the things that we're summarizing inside the app about the fire environment, so fuels, weather, topography. Our weather right now focuses on the 7-day fire danger forecast. So we have 7-day forecasts of the energy release component percentile and burning index percentile. Those are used to provide the severe fire danger index for the next 7 days. We have fuels and topography summaries as well. So land fire, using the land fire spatial fuels, but we're aggregating it up to simple fuel classes or categories that basically just tell you, is it burning in timber, is it burning in grass, is it burning, so what is the fire burning in, what's the slope and elevation around the fire area, and so we're currently summarizing values at risk for using the geographic names information system. And then we're building in the capacity to summarize building counts and population density for each incident as well. So there are lots of information fire by fire in the application. But one of the big things that we're trying to build this application for is to deliver the fire danger information in a consumable way so that we can put that into people's hands. So we, the last few years, have been working on an index, which we earlier referred to as the severe fire weather potential. And when we submitted the paper for a review, one of the reviewers was adamant that fire danger, it isn't fire weather, so they made us rename the index. So the same index that we've talked about before as severe fire weather potential is now a severe fire danger index. This index is just a combination of the energy release component and burning index percentiles, and produced as a forecast. So in its simplest form, what we do is we have daily daily calculations of the energy release component and burning index. We apply those calculations to a forecast grid from the National Weather Service, National Digital Forecast Database, and then normalize and categorize those forecasts on a daily basis to produce the severe fire danger index forecast. It's just a categorical forecast of low, moderate, high, very high, and severe, but it indicates where combined conditions lead to severe burning environments for both fire growth, but also impacting fires that could potentially impact both communities and firefighter safety. So we looked at some events from California for examples. So the panels on the left, the map panels, are actual forecasts that we produced before any of these fires were reported. So the Santa Rosa fires, the Thomas fire, and the Carr fire in the top panels, the Mendocino complex, and the Camp fire in the lower panels. All these forecasts, as I said, were produced at least the night before, up to 7 days ahead of time, so that these are available and can be in people's hands for real-time decision making. One of the other things that we did was look at the relationship between the severe fire danger index and firefighter entrapments and fatalities. And what we found was that a steady increase in the number of people entrapped, or the number of entrapment events, as the severe fire danger increases. This is especially important because these red bars only represent 3% of the days out of all of history for a particular place. So even though it only represents a very few days, it captures the majority between very high and severe, captures the majority of entrapments. More especially if you look at the upper right-hand panel, looking at the number of fatalities and entrapments, we see an overwhelming majority of the fatalities and entrapments occur under conditions that we're mapping as severe. So we know that the information is important. We know it's important for both community safety and firefighter safety. But what I wanted to do is look at some case studies from this year, using not the gridded data in this case, but rather weather from raw stations that would provide the same information that we need to produce the severe fire danger index, and it provides a forecast out 7 days in the current implementation in WEMS. So in the early part of September, we had a fire near Bozeman, Montana, called the Bridger Foothills fire. And on the 5th of September, we had a shelter deployment. And so if we look at the conditions for that day, the energy release component was over the 97th percentile. The burning index was the 99th percentile, but the forecast in WEMS actually had it at the 100th percentile. So never before recorded wind event of that magnitude for that particular place. But if we combine the ERC and BI to look at the severe fire danger index for this day, so this is the severe fire danger index daily, plotted as its respective categories. We see that the conditions for that day would have been forecast as severe. So, but as we carried on for the next couple of weeks in September, we had another shelter deployment from a CAL FIRE unit that was working on the Bear Fire, part of the North Complex in Northern California. And if we look at the conditions for those days, we see a similar pattern. So the burning index was the 99.6 percentile. So very, very extreme conditions. Historic would be an understatement for the wind event that they experienced there. This was the day following the strongest part of the wind event, but still the energy release component at the 98th percentile. And then when we combine those together to look at the severe fire danger index, again, we see that on the day of the shelter deployment, those conditions would have been forecast as severe. If again, we had another shelter deployment on the Dolan fire, and this was a little unusual, but if we use the same methodology with a nearby RAW station, looking at the burning index, the burning index is at the 98th percentile. The energy release component was at the 95th percentile. And if we look at the severe fire danger index, the only day out of the entire season with combined conditions that extreme was the day of the shelter deployment. And finally, if we look at the fatality on the Dorado fire, we see almost the same thing that we've seen in the other three examples. So we see energy release components at the 99th percentile, but actually setting new records for the 2 weeks prior to the event, and a burning index at the 98th percentile, and a severe fire danger index of a forecast of severe for the day of the fatality. Ultimately, time and time again, we keep coming back to this simple metric that is a powerful metric to characterize extreme burning conditions, both for fire growth, but also for safety. And the one thing that I just want to leave this group with is, how do we better inform operational safety? Because the best information in the world is useless if it isn't used to guide decision making. And we really need to better understand how can we integrate actual analytics, actual intelligence better into decision making. I'll stop there. If you want to try the WildfireSAFE app out, here is the address. Is just wildfiresafe.technosilva.com. My email's here if you have questions. Matt.jolly@usda.gov. Thank you.